Hi everyone. Today we're going to learn how to use the method of reduction of order to find an additional solution, y2, to a linear homogeneous ordinary differential equation. The first step we do is we make yg, the general solution, equal to v times what y1 is, in this case t squared. Then we derivatize to find y prime g and y double prime g using the product rule. Now we substitute y of g for y of g prime for y prime, and y double prime g for y double prime into this homogeneous differential equation. Then we multiply all of these out and combine like terms. There's only one term with t to the fourth, so we can leave that. There's two terms with t cubed and v prime, so we can combine these two. With t squared and v, there's three terms, so we can combine these three. And they end up canceling out. Now what we do is plug in w for v prime and w prime for v double prime. So this becomes w prime t to the fourth minus w t cubed equals 0. And then we make w prime dw dt. We subsequently make all the terms with t and dt go onto the right side and keep all the terms with dw and w onto the left side. We get 1 over w dw equals 1 over t dt. We then integrate with respect to w on the left side and integrate with respect to t on the right side. And when we integrate with respect to t on the right side, we add plus c1. This means e to the power of this term equals w. So we can rewrite it as e to the power of ln t plus c1 equals w, which makes w equal to t, since these two terms cancel each other out, times e to the c1, which we can just rename c2. Since w is equal to v prime, we have to integrate with respect to t once again to find what v is alone. So therefore, v is equal to the integral of t c2 with respect to t, which makes v equal to 1/2 t squared c2 plus another c called c3, since that c may be different from c2. Since we defined yg as v times t squared in the first step, and we know that v is equal to this, we know that yg is equal to 1/2 t squared c2 plus c3 times t squared. Yg is therefore equal to 1/2 t to the fourth c2 plus c3 t squared. c3 t squared, that's what y1 is, because t squared is y1. So this is the portion that we have to look at to find y2. And y2 is simply the term here without c2, since y1 is the term here without c3. So we know that y2 is equal to 1/2 t to the fourth. And that concludes how you use the method of reduction of order. Hope this helped everyone, and stay tuned for more videos. Thanks, have an awesome day.